Okay, here we go with the parabola homework. So the first grouping is to find the vertex, focus, and directrix of the parabola and sketch its graph. So the first two are where the origin is. I just realized there's a mistake there. The vertex is the origin. So number one. So the thing we need to do is put it in standard form. So it's not in standard form. It's in the form that we would normally plot something, but it's not in standard form. So what we need to do is multiply both sides by 2, actually negative 2, to get rid of the negative 1/2, and then just switch sides. So you've got x minus h squared equals minus 2 times y minus k. So we know by the fact there's no offset that h comma k, which are the coordinates of the vertex, are 0, 0. We also know that 4p is equal to negative 2, or p is equal to negative 1/2. So let's draw that, and then we'll come up with these values. We've got the vertex, and that's 0, 0. Okay. So the center, the vertex, you want to call it center, the vertex is 0, 0. Now looking at this equation, we have the axis of the parabola is going to be vertical because we have x squared and y, so it's either going to be this way or that way. Now, because of the negative in front of the y, it's going to be going downward like this, something like that. And because we're going through the origin, it's definitely going to look like that. The question is how far does it flare out, and where's all the other stuff? So we know it's going down like that, so the directrix has to be above it, above the vertex, and we're going to move 1/2 unit away from the location of the vertex, and then the focal point is right here. So what can we say about it now that we've drawn them? Well, this is a horizontal line, which means its y is equal to 1/2. So that's the directrix. And the point, the green point, so the focus is going to be x equals 0, y equals negative 1/2. So that's the coordinate here. This is the vertex. And that's the graph. Okay, one last thing is we need to draw it in. So we start at the vertex, which is the origin, and then we try to keep this distance between here and there constant to some extent. Something along those lines. And you can always, kind of pick a point and see if you're at least in the ballpark. So if I take the distance from here to there, and then from there to there, that actually looks pretty good. Okay, next one. In this case I got y squared instead of x squared. So putting in the standard form, you're going to have, so this is number 2, y squared equals negative 8x. So again, the vertex is the origin. 4p is equal to negative 8. So p is equal to negative 2. And because I have y squared, it's either going to look like this or it's going to look like that. Well, because p is negative, it'll be going this way. So it's going to look something on that order. So the directrix will be over here. The focus will be there. Okay, so let's get a piece of graph paper. So let's put a dot here at the origin for the vertex. The directrix, we're going to move 2 units. So it goes there, and then we can draw a vertical line through there. The focal point is the opposite direction, so that's the focal point. So let's go ahead and come up with these equations. This is a vertical line, so that's x. X equals 2. That's the directrix. The directrix is an equation. We have the focal point. So the focus is going to be y is 0 and x is negative 2. And then finally, we're going to start here at the vertex, and we're going to try to keep this distance between this and there reasonably constant, so this thing's kind of spreading out in this direction. Kind of like that. And again, let's just look at one scenario. So we go up here, that distance, and then that distance. So that's not too bad. Okay, third problem. So here, we're almost in standard form. We don't have to actually factor anything yet or use completing the square, but we do need to rearrange things. So you got y minus 2 squared is equal to negative 4 times x minus 3. Now, this is just like number 2. You got y squared, so it's going to look again like this, but the vertex is going to be at 3. Okay, I guess it's not going to let me move that. So the vertex, let's just write what it is. The vertex, look at the x1, that's 3, and the y1 is 2. So 3 comma 2 is about there, and then it's going to go this way. And that's because of the negative 4 here. Okay, so the vertex, 3, 2. As you can see, it's going to go to the left, so that means the directrix is to the right. We know that 4p is equal to negative 4, or p is negative 1. So if we move 1 unit this way and then draw a vertical line and then go the other way, same amount, that's going to be your focus, vertex, directrix. Okay, let's get the coordinates. We said the coordinates of the vertex are 3, 2, so that's the for the focus, it's going to be 2, 2. And this equation is x equals 1, 2, 3, 4. So the directrix is x equals 4. And then finally we're going to draw this thing in. Just kind of eyeball it. And I think I'm going to have you guys, draw at least one line so that you can prove to me you thought about it at least. So we draw that up to there, and then we draw down to there, and see at least they're in the right ballpark. Okay, next one is oriented the other way. Again, we need to put it in standard form, so we're going to multiply everything by 8. And then keep the x squared term on the right hand side, move this to the other side. So the negative 8 becomes positive 8. So we can see that the vertex is going to be equal to negative 2 comma 1. And you can't just say use this for x and use this for y by the order. You have to look at what variable is associated with which translation. We also know that 4p equals 8 or p equals 2. So now we can sketch it and then figure out the dimensions and the coordinates. I'm trying to avoid is just memorizing formulas. I want us to think about what visually is going on here. Okay, so the vertex is negative 2 comma 1. It's right there. P is, okay, so let's think about what direction this thing's going to go. So x squared, so we're either going to have this or we're going to have that. So it actually is going to go like that because we have positive p, and the vertex is at negative 2 comma 1. So it'll be like that. So as a consequence, the directrix has to be on this side. And it's going to be 2 units. P is 2, so we go 1, 2. And we go up 2 the other direction to give us the focus. And then we again try to imagine this distance equal to that distance. So again, I'm going to just check, kind of do a reality check here. So the distance from there to there is the same as the distance from there to there. Okay, so it looks good. And now, so we got the vertex from the standard form. The focus, you can see, has the same x value as the vertex, but it's 2 more units in the y direction, so it's going to be 3. And then this horizontal line is y equals negative 1, so the directrix is the equation y equals negative 1. I think that might be the first, yeah. That's the one we just did, and yep. Okay, just double checking here. Okay, the next grouping is, they're not in standard form, or they're not even close to standard form. So we're going to have to do a little bit of manipulation here. So probably the best thing to do first is to multiply by 4. So I get 4x is equal to y squared plus 2y plus 33. And let's switch sides because we want the squared part on the left-hand side. So if we switch the sides, we don't have to change the sign because they're both going to change. So, this, if it goes to the other side, it's negative. This goes to the side, it's negative. But then you just multiply by negative 1. So we'll take the 33 and go to the other side with that. Y squared plus 2y is equal to 4x minus 33. Now we're going to complete the square on the left-hand side. So we take 2 divided by 2, which is 1. 1 squared is 1, so we add 1, and we add 1 over here. Balance those out. Then this becomes a complete square, so you get y plus 1 squared. And here we have 4x minus 32, but the standard form factors out the 4, so that leaves x minus 8. Okay, so that's the standard form. Now let's think about what direction this thing's going. So it's got it's positive, and the y is squared, so that means it's going to go this way. That's because 4 is positive, and the center is going to be at 8 comma negative 1, so it's going to be really offset from the origin. So let's get our piece of graph paper. Now we do know at this point the center, or the vertex, is going to be x is 8 and y is negative 1. So let's go ahead and plot the vertex. 8, negative 1. Okay. Next, we need to figure out what p is. Well, 4p equals 4, so p equals 1. And because it's going to go to the right, we can do the directrix to the left, and we can do the focal point to the right, and draw a line, a vertical line here for the directrix. Vertical. So, and it's going to go kind of like this. We don't see much of it. Okay. Now, we have the coordinates of the vertex. The focus is the green point. So that has a y value of negative 1 and an x value of 7. No, 8, 9. Yeah, it's 1 to the right. The directrix, this equation is x equals 7. So the directrix is x equals 7. Okay. Let's begin. 3 more here that I think they're all in the different directions, different options, possibly. I'm not sure if it covers all of them. Okay, so we're going to keep the y squared on the left-hand side because that's where the squared stuff goes. We'll move the other things. The non-y stuff will go to the right-hand side. And you want to complete the square before you try to factor out here. So you got negative 4 over 2 squared, negative 2 squared, which is 4. So we add 4 here, and we add 4 over on the other side. So then we can rewrite this as a complete square. Y minus 2 squared is equal to 6x plus 6. Now that we've completed the square, we can now factor out the constant, which is 6. So we know that the vertex is going to be negative 1 comma 2. Negative 1, 2. Okay, what kind of curve are we looking at here? Well, we've got x squared. So actually, this is like the last one because we have y squared. So if you have y squared, then it's going to go this way. Let me do that. And then just shift it so the vertex is at -1, 2. Okay, let's do it a little more accurate. Okay, so we're going to put the vertex -1, 2 here. You can see that the directrix is going to be to the left, and we find that by saying 4p is equal to 6, or p is equal to 3/2. So if we go 3/2 to the left, that'll give you the location of the directrix. If we go 3/2 to the right, that gives the focal point. And we draw a vertical line here at -2.5. And then we can sketch in our graph. Something like that. And again, we want to draw from here to the curve, from the curve to the focal point. See how close these are. Pretty good. I'm getting better at this stuff. Okay, so that's the coordinates of the vertex. The focus is, let's go over here to the graph. So it's going to be up to, and this is -1, so you go 3/2, you get +1/2. So it's going to be x equals +1/2, y equals 2. And the directrix is a vertical line at x equals -5/2, because you go -1, -2, -5/2. So it's x equals -5/2 is the directrix. Okay. Now here we've got an x squared term. So we're going to leave the x terms on the left-hand side. Put everything else on the other side. So that becomes 12y plus 33, or minus 33. So the -12 becomes +12, and the +33 becomes -33. We take 6x, the 6 here, and we divide by 2. And we square it, so that's 3 squared, which is 9. So we add 9 over here, and we add 9 over here. And then this can be collapsed into x plus 3 squared, and we have 12y minus 24. So x plus 3 squared, factor out the 12, we get 12 times y minus 2. So our vertex is at -3, 2 from here and here, and 4p is equal to 12, or p is equal to 3. And looking at the form, we got y x squared, and p is positive, so what that means is it's going to be going that direction, and the center is at so let me redo that, and the center is at -3, 2, like that. So let's get some graph paper. So we got 10, 10, negative 10, negative 10. Okay. So let's see what we have to do. Vertex, negative 3, comma 2. It's going to go up like this, and P is 3, so the focus is 1, 2, 3 above that, and the directrix is 1, 2, 3 below it. So we can draw a horizontal line here, and that's y equals negative 1. And then we'll sketch this. So because this is further apart, it's going to, this thing's going to get spread out kind of more in this direction. It's going to be a little wider looking parabola. And again, we're going to draw in a line, focal point to there to the directrix. So that looks good. And then the coordinates of the focus. Let's look at our graph. So here's the focus. It's negative 3 is the x value, and instead of being 2, it's 2 plus 3, which is 5. And the directrix is a line. It's a line y equals negative 1. And the last one, this one. Well, it's not the last one. It's the last one in this group. Notice the x's aren't together, so you just got to be careful that you properly identify them. So you got x squared minus 2x. Take the negative 4y to the other side, becomes negative. Take the 13, becomes negative. Then take negative 2, divide by 2, square it, which is negative 1 squared, which is 1. So we add 1, and we add 1. So over here we can collapse that down to x minus 1 squared. Over here we have negative 4y minus 12. And then finally we factor out the negative 4, so we get y plus 3. And therefore the vertex is 1 comma negative 3. Now what does this thing look like? Well, we have x squared and we have a negative. So what that means is it's going to be down like this, except the vertex is at 1, negative 3. So it'll look kind of like that. Okay, so let's plot the vertex. 1, negative 3. Here's our graph. What is P? Well, negative 4 equals 4P. P equals negative 1. So because this is going down, the focal point will be here, and the directrix will be there, equally spaced relative to the vertex. And so again, you just eyeballing this in, something like that. Again, let's just look at this case. Yeah, actually it looks like I should have moved this a little bit quicker. I should have tapered this upward a little bit faster, but I just want you to show that you thought about it. We don't have to redo it. Okay, so then take our plot and get the coordinates. So the focus, you can see the focus and the vertex have the same x value, which is 1. And the focus is 1 step lower than the vertex, whereas the directrix is x minus or y, so y equals something. Y equals negative 2. Okay, so now we're going to go where we're given some information about the focus or the vertex, and come up with the equations in standard form. These don't take quite as long to do. And again, the best thing to do is to draw a graph or do a sketch. So let's do number 9. So it says the vertex is at the origin. So let's put a dot at the origin. And the focus is negative 3, 0. So that's over here. So if the focus is to the left, then the directrix has to be to the right, like that. So it has to open up to the left. So that means P, P has to be negative. And P is the distance from here to there, which is 3 units. So it's going to be P is negative 3, or 4P equals negative 12. So and also when you have it going to the left like that, it's going to be y squared and something x. So the y squared's, if we have y equals x squared, that's a parabola that goes up. This is one that goes to the side. So it's going to be of that form. So it's going to be y squared is equal to negative 12x. Because the origin is the vertex, we don't have any offsets here. We just have this P. Okay, next one, the directrix equals y equals 2. Okay, so again, let's draw in this line, or this coordinate system. And here is the vertex. And the directrix is line y equals 2, so it's a horizontal line. And the focal point is exactly opposite, the same number of units. So this is going to be 0, negative 2, and this is y equals 2. So that's the focal point, which you don't need to get standard form, but we do know that it's going to look like this, which means it's going to have to be of the form x squared equals something y, or y equals x squared is a parabola. Now it's going to be negative because it's going down, so we know P is negative something, and the distance from the directrix on the y-axis to the origin is 2 units, so that's going to be negative 2. So 4P is negative 8. And the final answer is x squared equals negative 8x. Okay, one more here. So here we got another directrix problem, except it's an x directrix, so you can imagine that the thing is going to be oriented 90 degrees, relatively speaking. So the directrix is a vertical line, negative 1. So there's your directrix. There is your vertex, and hence the focal point has to be right there. You might look at these numbers and think, oh, P is negative or positive, but it has to do with the relative position. So this thing it has to go out this way, like that. So what does that mean? Well, it means P is positive, and the distance from here to there, or from there to there, is 1. So P is positive 1, or 4P equals 4. And instead of having it as, before the previous two problems we had, well, actually, the last one was x squared equals y. Here we have y squared equals something x. To get this kind of curve, it's positive something, and it's basically y equals 4x is that. Okay, moving on to the next group, which is where we're given where the origin is not the vertex, so you got to think a little harder. But again, we can do this by sketching. We don't need to get a fancy graph paper or anything. So the vertex is -1, 2. And I think I've been using, blue for that. And the focus is -1, 0. Right there. So remember, focus, vertex, directrix. So the directrix has to be up here. So if this is 0, 2, 4, this is y equals 4. It's going to open up this way. So that means P is negative. And the distance from here to there is 2 units, so it's going to be -2. 4P is -8. Now the center, or the vertex, keep calling it the center again, the vertex is -1, 2. So, and the equation is going to take on the form of, because it's this vertically symmetric, you're going to have, y equals x squared. So you're going to have x minus h squared is equal to 4p times y minus k. So that's just kind of the standard form. So we've got x minus a -1 quantity squared is equal to -8 times y minus k. So that's x plus 1 squared is equal to -8 y minus 2. So that's standard form. Okay, next one, 13. So we're going to again sketch this. So the vertex is -2, 1. So that's here. Last one was -1, 2. The directrix is a line x equals 1. So that's here. So this is like 1, 2, -1, -2. It's 1. This is x equals 1. This point here is the vertex, so we're 3 units between the vertex and the directrix. So I need to go 1, 2, 3 right here, which is going to be -5. So the coordinates here are -5, 1. The coordinates here are -2, 1. And then you have that line. As a consequence, okay, so let's continue on this. So we have the coordinates of the center. We also know that it's going to go like this. So that means it's going to be x squared, no, the other way around. It's going to be y squared equals x something. So that form. It's in the negative direction. So p is going to be negative. So let's say p is going to be negative, and p is the distance from the vertex to the focus, or from the vertex to the directrix, which is 3. So p is -3, so 4p is -12. And the center, or not the center, the vertex is -2, 1. So here we go. We're going to have y minus, so the y coordinate of the vertex is +1, so we put a -1 there, r 4p is -12, and the x coordinate of our vertex is +2. So that's the answer. Okay, number 14. So again, let's sketch this out. So the focus is at 2, 0 right there. The directrix is y equals 6. So that's up here somewhere. So the focal point has to be, focus has to be down here. So we know that, and we also know that it's going to open up downward like that. So P is equal to negative 6 because this is 6, y equals 6, this is y equals 0. This is going to be y equals negative 6. So that means 4P is negative 24. And the coordinates of the vertex, oh, wait a second. Yeah, so again, I'm leaving this in here just because you can make the same mistake if you don't read the problems correctly. So let's redo that. So it says the focus is 2, 0, not the vertex. So what that means is actually that the vertex is halfway between the focus and the directrix. So this is y equals 6, and so now P is not negative 3, but it's going to be negative 3 instead of negative 6, because the distance from here to here is 3, and from here is 3. So it's negative because this thing's going down like that, because it has to go towards the focus and away from the directrix. So 4P is going to be negative 12, and the vertex, yeah, that was actually a little tricky if you don't pay attention to what you're doing, which I wasn't. So the coordinates of the vertex are 2, 3, because these are all lined up, so they have the same x value. This is y equals 0, y equals 6, and this is y equals 3. So, and again, we have this downward, so it's going to be x squared equals something y. Y equals x squared, but P is going to be negative. So what we'll have is negative 12 here for the P part. Then you have x minus h. H is the x coordinate of the vertex, which is 2, so x minus 2, quantity squared. And then you have y minus the y coordinate, which is 3. And so there's your answer for that one. Okay. Now we got some word problems, just 2 word problems. So here we have, it says a receiver in a parabolic television dish antenna is 4.5 feet from the vertex and is located at the focus. Okay. So the receiver, this is the vertex, and this is the focus, and this parabolic thing has to be sitting on the focus. Now it's actually a paraboloid, that's what they call these parabolas, but they're saying find an equation of the cross section. So what we're doing is we're looking just in the xy plane and not in this direction, the z plane. So if we did that, it would look something like this. So the vertex is at 0, 0, and the focus is going to be at 0, 4.5. So it's just like, once you've drawn that, it's just like the previous one. But because it's located at the origin and it's pointing upward, so it's going to be of the form y equals x squared or x squared equals y. And the only thing we have to do now is figure out what this multiplier is. We don't have to put anything in here with the x or the y because the vertex is the origin. Okay, and then this distance, this is p. So P, and it's positive 4.5 because it's pointing upward. So 4P is going to be 4 times 4.5, which is 20. Is that right? Or is it 18? It's actually 18. 4 times 5 is 20. So it's 18. So this becomes 18. So it's x squared equals 18y. And the last problem, it's okay. So because of the shape of this parabola, we know it's not going to be y equals x squared, but it's going to be x equals y squared. So we're going to have y squared is equal to something x. The question is, what is this multiplier? So what we have is we have 800 squared. We're going to plug in either one of these. We could plug in negative 800 or 800. It doesn't matter because when you square it, you're going to end up with the same number. And well, let's call this a. So we have a times x, which is 1,000. So 800 squared divided by 1,000, 640. So a is 640. And because it's pointing to the right, we know that a is positive. So we get y squared is equal to 640x. And let's just double check, see if we got the right answer. So if we plug in x equals 1,000, we'll get 640 times 1,000 is 64,000. Take the square root. We get 800, but it's plus or minus the square root of 640 times x, which gives us plus or minus 800, which agrees. We've got one value of x and two values of y. That's why it's not a function. So that's it.